Could you tell me the pH of it?
Yes.
Please do so. Doesn't this give off 0.010 molar OH and 0.010 molar Na?
Yeah.
So once you have that, can't you press negative log number and you get 2? But that's your POH. Subtract that from 14 and you get 12. Okay? Can everybody handle that? Nope, there might be a question like that on your test. Okay?
When is our test?
Wednesday.
Next Wednesday.
Let's go.
Let's go.
Okay.
Destroy.
Destroy.
Monday?
I come to destroy.
Now.
You didn't like the Monday test?
Well, no, it's not that. I'm just off in a funk here. I can't finish by Monday, and then so I was going to try and do Thursday, but we'll be finished before that, so we're just going to do Wednesday. Okay? Alright, so what if I do this? That's not what I want, it's this. 0.010 molar ammonia. What's the pH? Can you do that?
No.
Why no?
Because it's not strong.
It's not a strong base, therefore it doesn't ionize 100%. We did this yesterday with strong acid and weak acid. Now we're doing it today with a strong base, and now we're doing it with weak base. Since that's a weak base, it's going to have a KB value. And it's 1.8 times 10 to the negative fifth.
Right, how do we know
so
that?
now we have, I'll let you know that. Okay, I'll give it to you. So now we have a KC, KP, KW, KA, and KB. Okay? Now there's one little snafu, and Daniel, you brought this up earlier when we were writing out that reaction. When you do weak bases, like ammonia, add them to water. It'll make your reaction easier. Because what do bases do? They accept a proton. So what's over here?
NH4.
NH4 positive and OH negative. Okay? Lucas, you're all right there, bud? Yeah. So, if I write the K expression for this, it's going to be what? NH4 positive times OH negative all over NH3. So see if you can follow me on this, because I talked about this yesterday when we did Ka. Kb is always going to be the conjugate acid times OH over the base.
It's so much more complicated than last time.
It is complicated.
Oh, never mind. Never mind. It's still going to be X squared.
Wasn't Ka always the concentration of hydrogen times the conjugate base over the acid? Well, Kb is going to be the conjugate acid times OH over the base.
Is it still like X?
You see this base here? Base, OH, right? Acid, H. Okay? The base is down here. That's where that guy is, down there.
Yeah.
Acid, down here. Okay. Alright. Well, guess what? You do the same thing. Kb always equals
X squared over
X squared over concentration. Please solve for X. Negative, well, did you square root it?
4.2
Times 10 to the negative fourth?
Yes.
Yeah!
Okay. Alright, here we go. You ready? Eyes up here. When you use Ka and you solve for x, you get h. When you use Kb and you solve for x, you get OH. So when you press negative log number, that's your POH, your poo.
Cool.
Subtracted from
14.
14. Please do that.
It's a big pH.
And shouldn't it be? Don't bases have big pHs?
10.6.
Give me 2 sig figs.
10.63.
10.63?
62.
Yes, 62.
Yeah. Oh, okay.
Okay.
I got it.
Does that make sense? Okay?
That's definitely not what I got.
That's not good. Did you subtract it from 14?
Yeah, isn't it 14 minus 4.2 times 10 to the negative?
No. No, you gotta press negative log number first.
Oh, duh.
Alright, so once again, Ka, if you do Ka equals x squared over concentration and you solve for x using Ka, that's h. If you do Kb equals x squared over concentration, you solve for x, that is
KOH or
OH. OH, yes.
Is water not figured into the values because you're assuming you have a limitless supply?
No,
Like
because
in
it's a
the
liquid.
Oh.
And I don't use liquids, that's a good question. I
Right.
don't use liquids in my equilibrium expression. Okay?
I got you.
Does that make sense?
Yes.
I'm gonna take this one little, yes, go ahead.
Always want you to put into pH instead of
Not always. I'm gonna go one step further. Ready?
No problem.
What's that guy right there?
Conjugate acid?
That's a conjugate acid. Is it a strong acid?
No.
No, so it's a what?
Weak acid.
It's a weak acid. So, doesn't it give off hydrogen? What's left over? NH3, right? Doesn't it have a Ka value? What would it be here? What's this whole thing here? H positive, NH3, all over the acid, NH4 positive, right?
Yeah.
Does that make sense? Okay, everybody watch. Here's ammonia, right? Here's ammonia's Kb. I'm going to write it over here. What was it?
NH4 positive, OH negative, over NH3.
Okay? Everybody with me? If I multiply Ka times Kb, watch what happens.
EAK.
Why? 1 times 10 to the negative 14.
Good call. Baller status.
Ka times Kb equals Kw. So here's my question. What is the Ka value for ammonium? What is this guy? That's 1 times 10 to the negative 14. What was this for the last problem? 1.8 times 10 to the negative 5th. So, is it 5.5 or 5.6? 5.6 times 10 to the negative
10.
Does that make sense?
Yeah.
Okay. Alright, so Ka times Kb equals
KW.
Kw. Alright. Let's see what we got here. What is the pH of 0.1 molar ammonia if ammonia has a Kb of 1.8 times 10 to the negative fifth? See if you can do that. Like yesterday, Kb will always equal x squared over concentration, correct? Kb is equal to x squared over, where is it, 0.10, actually just 0.1, concentration. Solve for x, and apparently we're only doing this with 1 sig fig, so give me an answer with 1 sig fig. 0.001, is that what you said? Does everybody agree with that? Yes or no?
Yes.
Why didn't you just do the KB times KA equals 1 times 2? And then divide, like, plugged in the KB value and then divided it. I thought that's what you just showed us.
Okay, say that again.
Why?
Because the question doesn't ask what is the Ka value of, I'm not asking for the Ka.
Okay.
Okay. I'm going to take Kb, solve for x. When I get x, don't forget when you solve for, using Kb, when you solve for x, you just solve for what?
OH.
OH, that's right. And if I have OH, can't I get pH?
Yeah, you can.
Yeah, you can. Press negative log number. Is it 3? That's your POH, therefore the pH is?
11.
No.
11.1.
11.1.